We're over here at the control box to raise and lower all of the basketball equipment. Each basketball hoop is controlled by its own individual key location. There are 6 locations here. They are all keyed using the exact same key. To raise and lower, I will stick the key into the controller and I will turn the key to raise or lower. But before I do, I want to make one note of caution, that the basketball height must always be at the highest elevation before a basketball unit is raised or lowered. I will now begin raising and lowering it with the switch of the key. By turning in this position, I will raise the basketball. If at any time my finger will release from the key, the basketball unit will stop. I must then again re-engage the key and hold that down until it reaches its full position where it will automatically shut off. To lower it, I will turn the key in the opposite position and lower it. And again, if I let go, it will stop automatically and I will have to re-engage the key. It will lower itself all the way down into the down position and will stop automatically. I will let go of the key, remove the key from the switch, and that concludes the demonstration for raising and lowering of the basketball equipment.
This is the electrical section of condensing unit number 6. This is where we control the compressors and the condensing fan motors from. As you can see, we've got fuses in the upper right-hand side there. Those are for your condenser fan motors. Each one of the 8 compressors has a breaker here controlling that. We've got each one of the 8 contactors that control each one of the compressors there. This bank of relays right here is from the energy management system in the building that cycles the unit on and off. We've got a switch, it's a system switch right here that I'm pointing to. If we want to start or stop this unit, we're going to want to use this switch. It cycles down the unit. It's the control voltage side of the unit there. When we shut the unit off, turn this switch off, let the unit shut off, and then we can shut the main disconnect off. You don't want to do it vice versa. It's too big of a load to shut off. We get done doing whatever we're doing, flip it back on, the unit should cycle right back up as needed.
Hi, I'm Al with Connolly Electric. I'm here to talk to you about your lighting panels. What these are, the PowerLink G3 smart panels. What these panels are for energy management, and they control all your lighting, interior and exterior, throughout the building. They are controlled through software that you design yourself, how you want lights turned on and off throughout the building, as far as their occupancy and nighttime use. There are 2 separate overrides to this panel. You have key location switches in the hallways where you can turn lights on and override the software for nighttime maintenance. Or you can also override should the software programming go down for any reason through these buttons that make these breakers manually operated. There's a small white button with the designation of manual and auto. In the software mode, these buttons will be in and now controlled by software. In the event you should need to override because of the software issues, simply depress the knob, white button pops out, and the breaker is now turn lights on and off as need be throughout the building.
We're now standing in the northwest corner of the building. In the northwest electrical closet, you'll find the metering for all of the units from the breezeway north to elevator 1. In the southwest closet, the metering is picked up from the breezeway south to elevator 3. In the east closet, you'll find that you have the metering for the 2 slab units and then the middle section of all the units. This is the main disconnect switch. By throwing this switch into the off position, we'll turn off all the units that are fed from this panel. These are the meters labeled individually for each unit. When ComEd comes in, they'll come and read each meter and then issue bills accordingly. We'll now go over to the snow melt system for the ramp heat.
Hi, I'm Ed with Hayes Industries. Today we are going to be talking about the plumbing system. Right here we are standing in the southeast corner. This is where the main water comes in for the whole building. It comes in, goes through the first valve, which is the main shutoff. From there it goes into the water meter, which reads how much water is used, has a remote read on the outside of the building. From there we go into the isolation valve, which isolates the meter, hence if there's ever a problem with the meter. From there we go into the RPZ, which is a backflow preventer, which stops cross connections from contaminating the main water system. From there we are piped into the main mechanical room from there.
And we're in a typical restroom here, and we're going to be troubleshooting the toilets, urinals, and sinks. So we're going to start with a typical flush valve here and start with the most common problems and work our way through to just some normal troubleshooting tips. The only tools that you need to work on these valves is a flat screwdriver and a smooth jawed wrench. We don't want to use anything like a channel locks or anything with teeth on it because we don't want to scratch the chrome or destroy the cover. The number one thing to remember when you're working on Sloan valves is we always want to shut the water off first and foremost. So I'm going to start with that. Taking my smooth jawed wrench, I'm going to loosen this cap on the flush valve. Okay. Take our regular screwdriver and turn this clockwise until you can't turn it anymore. And that is in the off position. Now we're going to assume that the first problem we have here is a valve run-on, which means the valve was continuously running, water was flowing through the bowl, and we could not get it to shut off. So with the water off, now what we want to do is we want to press the button that is on top of above the sensor here, above the grab bar, and that will click, letting you know that we've relieved the pressure on the cover. Because when you have a run-on situation, all of the water pressure that you have on this valve is on this cover. So if we don't relieve the pressure, we're not going to be able to get this cover off. So again, using your smooth jawed wrench, you can then loosen the cover rather easily, and then the rest of it will come off by hand. What you're going to find when you take this outside cover off is that there is also an inside cover, plastic, and then a rubber diaphragm. There's going to be some water in there. And when you have a run-on situation, 90% of the problem lies within this rubber diaphragm. Over time, this rubber will wear out, and debris can build up around this plastic refill head here. And when that happens, the valve runs on. So the first thing that you want to do is take a look at the diaphragm. If it looks like it's in good shape, it could just be some dirt and debris has formed around the rubber on the underside or the plastic refill head that is part of the diaphragm assembly. So if you want to take this over to the sink and rinse it off real good, that might solve the problem. Typically though, the problem is going to be the rubber is worn out and needs to be replaced. So what I would recommend doing is replacing this entire assembly. And when you get the new assembly, all you need to do is just drop it back in place like so, put your inside cover back on, and then thread on your outside cover. Okay, that's one option. And that's the one I recommend because it's the easiest, and you know you have another 4 to 5 years out of this diaphragm.